In this course, we will get started with Terraform. But first, we will take a look at Infrastructure as Code or IAC and the different types of tools available in IAC and their purpose in managing the modern IT infrastructure. We will then see the role of Terraform in today's IT infrastructure. Then, we will learn how to install Terraform. This is followed by the basics of HashiCorp configuration language. Next, we have our very first lab, where you'll get your hands dirty working with the HCL syntax. Next, we will understand the basics of Terraform, such as providers, input and output variables, resource attributes, and dependencies. After this, we will take a look at state in Terraform, what it is, why it is used, and the considerations to follow when working with state. We then dig deeper into the fundamentals, starting with different commands provided by Terraform. This is followed by a lecture where we understand the difference between mutable and immutable infrastructure. Next, we'll take a look at lifecycle rules in Terraform, where we'll learn how to manage the ways in which resources are created. After this, we have lectures on basic topics such as data sources, meta-arguments such as count and for each, and finally understand version constraints in Terraform. After this, we have a dedicated section on AWS. This section begins with optional lectures and demos where we learn the basics of AWS, such as setting up an AWS account and learning about the basic AWS services such as IAM, S3, and DynamoDB. We will then see how to provision and manage these using Terraform. Each of these topics, including the ones for AWS, are followed by hands-on labs where we get to practice the concepts that we have learned. We will then learn concepts such as remote state and state locking with Terraform, and then see how to store state in a remote S3 backend. Next, we will see how to use Terraform state commands to manipulate the state file. We then have a few lectures and demos where we get introduced to the EC2 service and then learn how to provision it using Terraform. Following this, we will learn about provisioners in Terraform, what they are, the different types, the behavior and considerations to follow when working with provisioners. We then look at resource states, learn how to enable debugging, and then import other resources into the management of Terraform. Next, we will learn about Terraform modules, what they are, how to create them, and how to make use of the modules which are available in the public Terraform registry. After this, we have a few lectures where we learn about functions and conditional expressions in Terraform and how to test them using the Terraform console. We will then learn about workspaces in Terraform, what they are, how to create them, and when to use them. We will then wrap up this course with an introduction and high-level overview of the features that are provided by Terraform Cloud. In this course, we have video lectures that simplify complex concepts using animations. In the AWS section of this course, we have demonstration videos that are intended to help you get started with AWS and make use of services such as IAM, DynamoDB, and EC2 with the AWS Management Console. We have hands-on labs where you will get to provision and manage infrastructure resources using Terraform. You don't need to set up your own labs or create any cloud accounts. Our labs are embedded in the course and open right in your browser. To optimize the user experience, we have integrated Visual Studio Code with the labs. This will allow you to make use of the built-in Terraform extensions to write configuration files easily and then run the commands from the integrated terminal. You would also be developing configuration files that will work with the AWS infrastructure.
Output. We'll see how we can print some messages output, and we'll also talk about data sources. When we set up any infrastructure, it returns some value back to us, and because it makes an API call. An API call returns data in JSON format. Like if you're launching an instance, it will give information in return about instance ID, EBS volumes, public IP, private IP. So sometimes you would like to print those output also. So we'll see today how we can do that first, and then we'll slowly progress and understand backend Terraform states, and then we will launch our own vProfile project. So let's begin. So I have all the things that we did yesterday over here. I have the providers file. Let me zoom it. That mentions the provider. Then I have the variables file where all the variables are defined. Then we have instance.tf. Over here, we are launching the instance, and then we are copying a file, executing that file, and then in the connection, we are mentioning the username and the key to log in for that connection. So we'll take the same scripts that we used yesterday. I copied into different directory, removed the Terraform tf state file, but I'm going to do one more thing over here in instances. So yesterday I was talking about the key name that we are giving over here, specifying this. So whenever we create any resource, it returns output in return, and we can access that data sources. We can also access the keys when we are defining the resources. Here we are defining a resource where we are creating a key. So if you want to access this value or this value or any value that is defined in this resource, we can access that by giving the resource type, the name of the resource, dot any key inside that. So when I'm launching the instance, I need to specify the key name. So I can directly give the key name like this, as we did yesterday, or I can access this value over here. And that I can do it by giving the resource type name, which is this, dot vProfile key, which is this dot. That is, dot means inside that. You can understand for now. Or if you know the JSON, it will be the key name, which is this one, that returns this value. So we want to access this value. So we're using this data source over here. And as it's a variable, we put them into dollar curly braces and in double quotes, right? Similarly, when the instance gets created, we can print information by using output. And you can give anything over here, like I want to print the IP address. So I'm just going to print IP. It will just print the text IP on the screen. And then in our curly brace, I'm going to mention the value that it is going to print for the IP. So I'm going to say value equal to, now I want to access the public IP. I want to print the public IP of the instance. So the resource type AWS instance and the name of the resource that I have given, my instance, then it is going to return all that value. From that, there will be a value called as public IP. So that I'm going to print. So in double quotes, again in this format, we give AWS instance dot the resource name that I have given over here dot, and I'm going to say here public underscore IP. So that's one of the resource one of the key which it gets printed, okay, when we create this instance. So let's save and quit this. And first we'll do Terraform init, because this is the first time we have created all the scripts. Then I'm going to say Terraform plan, which will show the plan of execution. Okay, now in here you can see things that it may return, which you can use, like public IP. If you want to print private IP or private DNS name or subnet ID, right? Or instance state, instance type, all these values you can use to print this information. So we have used public IP. Where is that public IP? So right now there's nothing because it's just in a planning state. It has not yet allotted the IP address. When we say apply, say yes, excuse me. So mostly when you launch the instance, you need to log into those instances. So you'll need the IP for it. So instead of going to AWS console and getting the IP and then logging in, you can do it from here itself when it gets printed. So we'll wait for a moment. Okay, just give me a moment. I'll be back. Okay, I'm back. So the instance is created and we see in the console, where's my cursor? You see the public IP over here. No, not that. That's our instance. I need to change its name. Yeah, 142.115. Let's check. Did it printed? You see that? Outputs IP and it printed the IP. Okay. So when it launched everything, the script execution. So public IP, right? When it was launching, when it launches, it doesn't get public IP. After some time, gets the public IP. So at the end, if we are printing, we can see the public IP, right? Which is useful. Then you can use it to log in. So we have our key, webpro key, and we know the username Ubuntu @ and you can use public IP, and you can log into this instance, right? That's nice. Okay, now I've explained you about Terraform TF state file. Let's open that file. So as I told you, Terraform is one automation tool for cloud that maintains the state. Like there's this cloud formation, right? That was by AWS, which maintains the information about what's the current state. Apart from that, there's only Terraform, right? Which can do all the different kinds of automation and also maintains the state of what it has done to the infrastructure into its Terraform TF state file, right? So all the values that we are printing actually gets recorded over here, then it's printed from here. You see that public IP, right? Private IP, private DNS, right? All that information you can use and you can print it. Not only print it, you can use it. But now there is one problem with this file. When you are maintaining a state, the state is maintained in a directory. And if you're working in a team where everybody is working on the scripts, right? Everybody is working, let's say in this output directory, and they're writing scripts in your team, different people. So the state is recorded locally on your system. But when someone else are using the same scripts from the version control system, they will not have this state. They may have a different state file, and which will be in conflict. So from here, if you execute, it will do some different action. But if you execute from someone else's system, it may do a different action. It may not find the Terraform TF state file. It will feel that instance is not created, or if it's there, it will delete it and recreate again, which is quite dangerous. So you need to maintain the common state of this file, Terraform TF state file, which can be done by using backend. We can use S3 as a backend service where it will maintain this Terraform TF state file in the S3 bucket. And anybody who is using this version, through version control through anywhere will have the Terraform state file accessing from the S3 bucket. So to not have this Terraform state locally, but have it in S3 bucket, we may need to do some changes, and that we will do now. Maintaining the backend state. It's like a centralized database, right? You can't have database locally in the system. It should be centralized like that. It's maintaining the state. It's kind of a smaller database. So it should be centralized, not local. So let's copy all that into a different directory. First, let's delete these things. Let's destroy. Terraform destroy. So it created the key and created the instance, and I'm destroying both of it. Okay, this is destroyed. So keep destroying your instances once you're done with the practice, right? Because not a console, you can't really see what's its instance is running or not. So let's get into backend. Now backend is, I'm saying that we are going to maintain backend through S3 bucket. For that, Terraform is going to use AWS CLI and access the S3 bucket. So you need to install AWS CLI, sudo apt install AWS CLI. Yes. So it's not going to use its own Terraform resources to access the S3 bucket. It's going to use the AWS CLI. And when you set up AWS CLI, you need to set up authentication also for that. So we are going to do that. So AWS CLI is installed. Now we are going to say AWS configure, which will which will ask the access key and the secret key and the region. So I'm going to enter that, but I'm going to unshare my screen so you don't see my keys. It's simple. You just have to take from your credentials file. So for the IAM user credentials file, you put your access key, secret key, and the region, hit enter, and it will be saved. So I'm going to unshare my screen now. Let me get my credentials file. I've moved it to somewhere else. Not this one. So you can use the same IAM user what we created yesterday, or you can use a different IAM user. I recommend using a different IAM user for this one. Terra admin. I'm going to generate new keys now. Uh-oh. Entering the access key. Entering the secret key. Now let me share the screen. Okay, so AWS CLI is installed. I have added the access key and secret key when it asked. And now let's create a backend file. So I'm going to name that file as a backend.tf to give Terraform and you say backend S3 and then you give the information about the S3 bucket. So we'll create an S3 bucket. So first let's create the bucket, that will be better. So otherwise, if it doesn't allow us to create the S3 bucket, that will be other problem. So let's go to S3. Let's create a bucket. Terra state hyphen 586, some random numbers. I'm going to keep the same region, North California. Make sure your Terraform state file is in the same region from where your Terraform instance is. The access will be faster. Okay, because Terraform instance where you're running a script will access this S3 bucket and store the Terraform state file in the bucket now. Terra state 586. Let's come back. So let's give the bucket name in double quotes. Terra state hyphen 586. That's what was the name, right? Find out. Key. So to give a key, this key will simply create a directory and then a subdirectory inside that and a file. So I'm going to give the name as Terraform, so it will create a directory in the S3 bucket with the name of Terraform, and I'll give the name of the key backend demo. So in this, it will create the Terraform TF state file now. We can mention one more detail over here, which is region, which will be better. Otherwise, it will keep asking us in which region do you want to save. So I'm going to say US-West-1, which is North California, the region of the bucket. If you give this wrong, it will error out. See this. Okay, let's run Terraform init. So it's asking, do you want to copy existing state to the new bucket? Because you already have a state over here. We cancel this out. So I want to remove this state because this is the state of the previous one. Okay. I don't have any state now. Okay, let's do now Terraform init. So when I copied the file, right, from directory from the previous one, it copied the Terraform TF state file also. Now let's run Terraform plan. So if there is any error, we'll see it over here. There is none. Let's do Terraform apply. Yes. Now everything remains the same what we did previously, except now the state will be stored in the S3 bucket. Now if anyone who is using this same source code will have the backend file there, but they have to install AWS CLI and provide the access key and secret key so they can access the S3 bucket. So Terraform can access the S3 bucket. Okay, so everybody will then have the same state file. So it's very good when you're working in a DevOps environment where multiple DevOps engineers will be contributing and writing scripts, Terraform scripts. Okay, this is a must to have backend state in the S3 bucket. Okay, let's go to our S3 bucket and see if anything happened there or not. Nothing yet. Okay, probably it will happen after this. You know, in the backend, all the automation tool does the same thing. You know, they make API calls to AWS. When the API calls are made, then the response comes back into JSON format. So every tool handles it differently. Like Ansible, if you talk, it will just print it can print all that information. You can store that into a variable and print it, but doesn't really store it anywhere. Terraform stores it into the file, Terraform TF state file. You see, there is no Terraform TF state file here now, right? Because it is there now in S3 bucket. Let's see, let's refresh. Okay, you see that directory now, Terraform, and you see that file. That's our file. So you can download it. Can open. Now it's going to open it in Notepad, so it's going to be printed in just in one line. Right, come on. Yeah, little uglier to look. Check this out because it's Notepad. If it's Notepad++, it will print it properly. So the state is mentioned in the S3 bucket. Okay, this is one must to have if you are working in a team and everybody is working on Terraform. If you're the only person who is doing Terraform, right, then it's fine. You can maintain the state in the local also. Okay, clear this one? Hello.
Yes, that's fine.
What kind of permissions are supposed to be given to the user? Oh, I am user. For the S3 bucket, you can give normal permission to access the S3 bucket. You don't need to give all the permission. S3 bucket full access is fine. Conclude session today. I'm on journey. Okay. All right. Okay, so we're good. Oh, let's delete it. Terraform destroy. Let me see what's next in our plate. Delete, yes. Okay, and I'm sorry, I was on mute. Okay, so I was saying, so far we have seen very basics of but really very good information about the Terraform. By using all this information and by using now the documentation, you can launch any resource or you can set up any resource of AWS. So we will take example of our project now, vProfile, that we have learned. Now we build it, deployed it on Tomcat server, then we can put it under load balancer, then we can set up database also, right? So we will see that with example now. So let's begin now. We're going to begin from, so let's copy from the previous one, providers file. Uh-oh. What? Wait. From backend everything to, let me create a directory, vProfile. Okay, so the providers is going to remain the same, no changes there. In vars, let's see what all we can put. Okay, vars is also fine. You're going to use this same key, a pro key, which is already uploaded there. Next, we have, so security group, of course. So let's create the security group. All right, so we're going to write a file to create security group. So I'll name it as security group.tf. Okay, now I can mention security group, all the information in instance tf file also. Okay, but having it separate always will help you. Key created in a separate file, the security group created in separate file, instance launch it in a separate file, elb launch it from a separate file. Okay, it's a good distribution. And don't worry about connecting. Most of the time Terraform is going to create it as per its own design, and the proper what I can say, priority, like first security group will create it, then key pair will get created, then instance will get created, then the load balancer will get created. Okay, But if there is a failure of a priority, if it's doing something first and then later which you don't want, then you can use one resource, one setting called depends on, that we'll see. First, let's give the resource. Now security group. So now I want you to become independent. Whatever you learn about Terraform, it's very good start for you. Now it's time for you to become independent. So go to the documentation. You don't know how to create security group, no problem. Go to the AWS documentation and look for security group. So there's AWS security group there. AWS security group. So make sure in the URL check this one. It's R, not D here. D means data source. Okay, because initially these are all data source information. Okay, and you'll be checking that and you won't find right example. When you scroll down, when the data source is completed, from here the documentation starts. Here, code documentation starts. Okay, so make sure in the URL is R here. Okay, that's one thing you should keep in mind, otherwise you'll be really thinking what I'm really reading. Okay, so that's security group, and that's how you can create. Okay, and simply copy this, but let me explain you this first. So AWS security group, the group name, the resource name. Okay, name, this will be the name of the security group. You can give some description. You can specify VPC ID if you want to create the security group in a specific VPC, because security group are VPC specific. Okay, for the new batch we'll learn VPC later, that time I'll explain you. But if you don't mention, it will get created into default VPC. Okay, then you mention the rules. Now there are two kinds of rules, inbound and outbound. So in networking, it's also called as ingress and egress. Ingress means inbound, egress means outbound. Okay, so mostly outbound we give full access. Outbound all the traffic can go, but the traffic that is coming in, for that we set the rules. Okay, so here more examples. CIDR block, can give the CIDR block, and egress rules, endpoint, timeout, right? So nothing too much complicated here. You just need to understand how to set up the security group rule. From port ingress, from port to port, which will be the same values. Protocol -1, this means allow all. Okay, these are few things. Apart from that, you can give the CIDR IPs and all. So let's write our own security group rule. So I have it here with me. Just paste it. Okay, so AWS security group, name of the security group, sorry, name of the resource. This is going to be the name of the security group that I'm going to create. Okay, description, egress, outbound. So outbound, traffic going out, mostly we give all. So from port 0 to port 0 means, this means all the ports. Okay, from all the protocol -1 means CIDR block, and this is going to be the list. So the first element in the list, 0.0.0.0/0. That means outbound all the traffic to all the IPs. Ingress, incoming rule. So this security group is for our vProfile instance, where we'll set up the Tomcat. So you need to do SSH to that, right, to make changes. So we'll set up the rule ingress. Just port 22 protocol TCP CIDR block, and this is my IP. So you need to find your IP. My IP. Get your IP. Same. Yeah, same only. /32. That's the subnet. Okay. Now I'm going to set up this security group is for our Tomcat instance, where Tomcat service will run on port 8080. Okay, and I'm saying port 8080 is allowed from everywhere because I'm hosting it for everyone, so it can be accessed from the internet by anyone. It's a website, so allowed from anywhere, or you can give specific IP security group names. Okay, there's one more ingress rule I'm setting up. This is for the Terraform. So we are going to set up Tomcat through a script. So Terraform is going to log into this instance through SSH, execute a script which will set up Tomcat and database. So now here I'm going to give rule for the Terraform, port 22 allowed from Terraform instance. Let's get the IP of the Terraform instance. And this is important, otherwise, your provisioning will fail. Okay, if you don't have this rule. Now, previously, so far, whenever we launched the instance, it was created in default security group. Now we are creating our own security group. Okay, and if I want to access this name of the security group, I will say AWS security group dot wiprosg dot name, which will return the name of the security group, and that I can put in the instance. So that was about security group. Okay, see what we have next. We have the instance, of course. So we're creating key pair over here, and I'm going to take this out and put it into a different file now. Key.tf. Should I say login key.tf? And from the instance, I will remove that. Okay, so even though I mentioned it over here, resource which is in a different file, Terraform will access it from the different file and apply this information over here. And so you can refer it into different file. No, Zai, that's not possible. Okay, that's really not possible. If you're not here, there's lot many things we did. So you can go through the video. Okay, you'll get the video. Okay, so we have the instance, but we are going to do some provisioning over here with some script. Those scripts are going to be a little different. I'm going to put here. Wait a second, I have a different script with me. So I'm going to write a different script here. I'll show you that. It's not really a script, just a series of command. tom.sh, which is going to, this provisioning is going to copy the script to our instance, and remote exec should execute that script for us, which will set up Tomcat for us. Okay, connection information this, and we'll print the IP of it. Okay, now let's write that script. I already have it written. So we know how we do vProfile setup, right? We need JDK, we need Maven, and we install Tomcat. We start the Tomcat service. We clone the source code, vProfile source code. We go into that source code. We run mvn install, which will generate the artifact, right? And then I'm stopping the Tomcat service and putting it for sleep for 20 seconds, removing the default Tomcat application. Start with the name of root, and then copy your artifact to the web apps directory with the name root.var. And then also I can upload application.properties file, okay, which I will customize by myself. And first I have to upload that into the instance, into this destination, and then I'm going to put it into the web apps directory. Then start Tomcat service and sleep for 120 seconds, then resume. Okay, so that's a simple script. A second. And I'm going to do one more thing now. We're also going to set up the database. So let me write the database script also. And we're going to push this script also to the instance. I need a fully functional vProfile, and for that we are going to need, what's red here? Mhm. Okay, so this script is going to set up MySQL database for me, user root, and the password is also root. It's going to enable remote login, create the database accounts, grant full permission to the accounts user, sorry, root user to access everything, and then use our SQL file, which will be in our source code. So in the Tomcat script, we are going to copy the source code, right? And just a moment. Okay, just give me a moment. I think I have a better one. Hold on a second. Let's do one thing. Yeah. So let me ditch all this script and just write everything in just one script. vProfile hyphen setup.sh. Yeah. So here I'm setting the build process, just building the artifact, install JDK, install Maven. And you see I'm running apt update 2 times over here. I told you yesterday we encountered a problem, right? With our Ubuntu 18 AMI, apt update is not working for just for the first time. So that's why I'm running it 2 times, installing JDK, installing Maven, cloning the source code, and building the artifact. Then I'm setting the database. Why it is showing red from here? Everything is properly coded. So I go to the home directory then and set up the database password. When I do this, okay, so we don't have time to explain this one because it's just a script which is going to set up the database. We can go through this later. Simple scripts, search and replace some content in the MySQL configuration file, create the database, and grant permission from the remote also, and we cloned the source code. And when we clone this, source code gets created into the home directory of Ubuntu user. Okay, so in this path we'll have the dbsql file which we are restoring. Then we set up the Tomcat. Okay, an application.properties file. This file also we are going to copy to the instance, and from then in the instance we are going to copy it into that directory, which will have the information about the database, right? Where to connect to. Okay, now in our instance file, I also need to create application.properties file. So you don't have to create this one really, right? It's in our source code. You know that already. So Tomcat is going to use that information, or application will use that information and connect to the database. I'm setting the database on the same instance. So localhost 3306, username, password. Okay, that's our application properties file. Now in our instance, we have to copy first our script. Our script is not tom.sh, it's vprofile setup.sh. So let me search for Tom and replace it with vprofile hyphen setup.sh. Okay. Before this, we also need to copy our application properties file. Application.properties. Oh, .ssh. It's 2 time sh. To remove that. Application.properties. have to make sure I copy it before I execute my script, because in my script, it's going to take the application properties file from here and copy it to the Tomcat destination, right? So I have to copy it before I execute my script. There is sh 2 times now. .sh and replace it with .sh. This is better. Okay. So launch the instance, and now the instance name we have to give different. vProfile hyphen instance, yeah, like that. Okay, now T2 micro will not be enough. Okay, so this is going to go out of your free tier, because I'm running Tomcat and database also on the same instance, and 1 GB of RAM is just not enough, so it's going to fail. So you have to give minimum T2 small. Okay, if you do this exercise with T2 small just for once and then delete it, the charge will be very minimum. Okay, 1 or 2 rupees, right? So you can try that one. Okay, it's not going to, but if you keep it running, then anyways, T2 small is not in free tier, so it will be charged hourly basis. So keep that in mind. Okay, all right, so far so good. What else is remaining? Okay, so we have done enough. We'll add load balancer also, but let's first Terraform init. Let's Terraform plan. Okay, looks good. Let's run Terraform apply. Okay, yes. So this is going to take some time, okay, because our scripts execution is going to take time. It's installing JDK, Maven, then it's building the artifact, then it's installing Tomcat database. So it's going to take quite some time. But this is mostly complete workflow. But if you put the load balancer also, and then we can add RDS also, that I'll show you now. So let it complete. I'm going to put myself on mute for some time. Once it's completed, I'll be back. we got some error. Security group Wipro-SG-1 already exist. I think there is a conflict now. So security group name. That's bad. I've given a security group name that really already exists. Should have given a different one. So security group 212. This is what happens when you don't delete your resources. I created this previously, I tested this one, so it's already there, that security group. Now it's conflicting with the security group that I'm creating now because they both have same names. Okay, so let's try to change the name and try to do this. And this looks now, let's see the plan. I don't want it to delete. Okay, nothing is going to get deleted. It's only the security group that will change. So Terraform apply. So don't just run the plan, just also see what really it is doing in the plan. You see, it will show you that it's going to make changes over here. Security group. Yes. Okay, that is done. Okay, first let's log into the instance and see our script have executed successfully or not. So we use a Wipro key. What's our key name? Wipro-key. Okay, SSH -i. Wipro-key. Ubuntu. So you see, printing information like this is helpful, like public IPs. I always like printing public IPs because I always want to make a test, by myself, a human test. So that's our source code, we did git clone, it cloned the source code. So let's go to the temp directory. We should have our scripts also there that we copied an application properties file. So that's our script. That's our application properties file. And when it executed, it should have set up Tomcat, MySQL and all. So let's check. Let's become the root user. Let's go to var lib Tomcat web apps. Right. Let's go to root and web.inf classes and our application.properties file there. It has copied this one. Let's see. It's the one that we copied. Yes, it has the right information. Okay. So Tomcat is set up good. Let's check MySQL -u, -u user root -p. I have given password also root. Logged in. Show databases. Okay, accounts database is there. Let's select that database. And now let's see, show tables. The tables are also created. So schema is good. So MySQL is set up here, Tomcat is set up here, our application is deployed. And now what I did with my script is I'm cloning the source code here, I'm building the source code over here in the artifact. But if you have a separate continuous integration pipeline, which you'll definitely have if you're for DevOps, then you will store it into some repository like Nexus, right? So you don't need to build it. In the script, you can say, just wget download it from this URL. If you download your artifact, and then you can deploy it. So no, the deployment time will be slower, okay, smaller. So that's one thing. So let's exit from here. We come back to our Terraform instance. And let's check once from the AWS console also. All right, so that's our instance. Okay, T2 small. You see that? T2 small. Tags. Okay, fine. Security group. What? It is created into default security group? This is not good. Why did it create in default security group? Okay, we have a problem. Let's check our instance. Great. We have not mentioned the security group here, right? We should have mentioned the security group. Then only we'll come to know that, then only it will launch the instance in that security group. Otherwise, by default, it comes into default security group. Okay, so that was a mistake. So let's make that change. So we'll say security underscore group. That's the key. Okay, groups, and it's a list. Okay, so we'll give the security groups name. So first, only one security group name that we're going to provide. So AWS underscore security underscore group dot, and what is the name of our security group? Let's check that once. Wipro-SG. Okay, that's the name of the resource. Wipro-SG. So you don't mention the static names. Okay, static values, access it from the data source. Dot name. If you're creating security group in a VPC, in a separate your own VPC, then you don't give security groups, you give security groups ID. Then instead of name here, you just give here ID. Okay. So, but where you creating normal security group, that's good. Oh, I should have put it into curly brace also, right? Right. Again, you can check the documentation. Let's go to the documentation. AWS underscore instance. How do I know the value is a list? Because I have seen it here. It's not in an example. So let's see here different other keys. Security groups. Optional, a list of security group. That means I have to provide a list. So list is in square bracket. Okay, and then you can give multiple security group also. You can give security group IDs also. So if you are accessing a special security group, we created your own VPC, and that security group you are accessing, then you need to give the ID. Then it will be the resource type resource name dot ID, not dot name. Okay, you want to put your instance into a special subnet, you can give the subnet ID also. When we are doing high availability between two subnet, this will be important. So you see there are a lot many things over here you can use. Volumes, volume tags, right? So always check through the documentation. Initially you may have little trouble, but I've already given you a good start. If you follow this, and then it's all about reading the documentation and using the right resource. So now let's do Terraform plan and let's see what happens. I've changed the name. So 1 to destroy, it is going to destroy 1. Forces new resource. Instance, new resource required, IT. Okay, so this is going to be once again. All right, so we have to do it now. Terraform apply. Yes, this is going to again take some time. Okay, it's going to destroy the instance and recreate it, because you can't change the security group names. Okay, you can add security group names, but you can't change it. Just give me a moment. Mute myself by the time you watch this. Okay, so while this is happening, if you have any question, you can ask me. Yeah, Neil, we have few more things to cover. I have gone through the email, going to arrange a session. Don't worry. Yeah, Harika, we're going to share the recording. Yeah, again, Zaid, you have to go from the yesterday's session and then go through today's session once again after you're done with it, okay? Okay. So are you liking it, Terraform? What's your feedback on Terraform? Hey, can you hear me? Okay, liking it a lot. Good. That's nice. Because this is a tool that you can really can't compare it with any other tool. It's purely for cloud automation, but it has given more. They are including more and more providers, but it's basically the best cloud automation tool in the market. Okay, it's
Imran,
use other
I
tools.
have a small question.
Yeah,
Uh,
yeah.
yeah, we are using this, but some of the user will do the changes manually. And if you are trying to use the Terraform later, so that is going to conflict,
Over
right? So how
override.
we need to fix this? Yeah,
Terra,
it will
see,
override.
Terraform has no concern about who did what manually. It has a state file. Okay, so it will compare the state file with the state of your system. If there is any change, it will apply it. So let's say I have made some security group changed manually, right? And then my Terraform TF state file that is not updated. So when I do Terraform apply, it will compare the Terraform TF state file and your setup file with the state of the system. So security group rule will be different. So it will override that change. Whatever user made a change, it will override it, remove it or update it, depends. So see, it's like that. If you're doing something with a tool, automation tool, you have to make sure you do all that always with automation tool. Okay, you don't really do manually things. That I have been telling from the beginning, like from the Vagrant itself. I'm telling you this. When if you're using Vagrant to automate your VMs, use always Vagrant. Then don't do manual change. If you're using Ansible, if you're using Puppet, anything, any automation tool for anything, once you're using it for that purpose, use it. You have to use only that tool to make changes. Don't make any manual change. If at all, there are situations where I myself have made manual changes because there was no time, then I have to make sure that I do the same in the script. Okay, so there is no conflict. All right. So in the desperate time, you have to take the desperate measures. So yes, sometimes you have to make manual change, but make sure you go back and make changes in your script also. Okay, so let's check now our instance security group. And this is terminated. That's a new one. And yes, it's in our security group, which has right rules. Okay, so 8080 from my IP. Okay, now this is going to take some time for our instance actually to really come up. By the time, what we'll do is we're going to set up a load balancer in front of it. Okay, again, you have to become now independent, and you just need to find your right resource, AWS_ELB. That's your resource name. Click on it. It's D. See here, I've gone to the wrong documentation. So I'm going to go back. AWS_ELB, enter. Not this one, not this one. That one. Click on this. Yeah, this is correct. So real simple, okay? You know what? I'm just going to copy it directly from here itself, and then I'll explain you. So, you'll gain a confidence that, yeah, after the session, I can do it myself also by reading through the documentation, okay? Let's take that and let's go to our instance. And we'll write elb.tf. Now if you see, I'm mentioning everything in different file, but I'm not mentioning any order which one should get executed first. So Terraform most of the time, as I told you, will get the right order. Okay, that it will launch instance first and then it will create load balancer. But sometimes there are situations where it does one thing first and the other thing later. Okay, based on its own intelligence that you don't want. So you can use then depends on resource. Okay, depends on. I'll show you that next. I just copied it directly from there. So let's keep changing the name. AWS ELB, that's the resource name. What is bar really? So let's give the resource name as Pro ELB, and this is going to be the name of the load balancer. So let's give name as vprofile -tom -elb. Availability zone, so US West 1A. When you create a load balancer, you have to specify the zone. Okay, so here you can specify that, and availability zone value is a list and not a string, so it's in a square bracket. So in North California, we just have two zones, 1A and 1B, so we're going to mention both. Access logs, I'm going to not use the access logs. For the new batches, you don't know access log, how we can do it. For previous people, you know, through a S3 bucket, we put the access logs. Listener, so we instance port. So instance port is going to be 8080, where Tomcat service is listening, right? HTTP protocol. Load balancer port, let's keep 80. Now this will launch a classic load balancer. Okay, for application load balancer, there is a different resource. Okay, it's AWS application ELB. This is for classic load balancer. And one more listener. Now, if you have HTTPS 443, you're going to use 443 port, HTTPS secure port, then you also need to create certificate. Now in AWS, you can create your own certificate, and then you can mention the ARN name over here. So it will upload the certificate also. If you don't have this, to understand more about certificate, in the book, last chapter is there where I've explained how you can upload a certificate, SSL certificate to the ELB. You can also create SSL certificate in AWS itself. There is a service for that. Okay, and then you can attach it directly from there. That's much easier and better. Health check, let's keep it this, but the target is going to be health check for the instance. Okay, so instance is on 8080 and it's going to return the URL, right, value and login. So when we access the instance, IP port 8080/login, you get the vProfile login page. So that's our URL to access. And instances now. So we have to give instance ID. So AWS_instance, the resource type, and our resource name. What's our resource name? Let's check it. Head instances. My inst. I should have given a better name. Huh? .id. Cross zone load balancing. If your instance is in different zone, load balancer is in a different zone, it will work out. But anyways, we have just two zones. Both the zones we have kept over here, and our instance can be in either of the zones. Okay. Right. So ideal timeout, connection training, tags. Let's give some tag. vProfile -tom -el. So that's our load balancer information. Okay, let's just validate it once again. We have given the name, two zones. Listener is this instance port 8080, front end port 80. If you're using any other protocol and port number, make sure you make the changes over here. Okay, like FTP and all, or SSH. For SFTP and all, you can do that. Health check. Okay, things looks good. If you have multiple instances, this is a list. So you have to just say comma and give the other instance. Okay, we just have this one instance. So let's see how that works out. Terraform plan. Okay, things are good. So it's going to set up the load balancer. It is saying, let's say Terraform apply. Now I have not mentioned the security group, so my load balancer is going to use the default security group. Okay, but if you are creating a separate security group for load balancer, which you should do, then in security group file, create one more resource, create one more security group there, and then put that information into the load balancer file, that this is the security group for you. Okay, as we did same for the instance, similar to that. Okay, so check the right value. Okay, already exists. Great. There's a conflict. Already have a load balancer here. I think this is when I was testing these scripts. Yeah, action delete. Yes, delete. Okay. See, this is what happens when you do things the other way, not through Terraform. Conflicts. So yeah, as I was telling you, you asked me a question. What if there's already manual changes being made? So there is a Terraform import which can import the state of your infrastructure, but as I told you, sometimes it's giving some issues. It's not that stable as per my view as of now, but it will become stable. So if you even if you make manual changes, you can import those changes also. You don't need to make changes to your script. Okay, you can import those changes, and that will be imported into Terraform tf state file. Okay, sometimes there are conflicts for that, so right now I don't really recommend that one, but it will become stable in some time, I guess. So load balancer is also created. Let's check our load balancer now. Okay, load balancer is set up. Type classic, both availability zones. Let's check instance. It added the instance and it is saying out of service. Okay, it's still registering. It's in progress. Let's manually check our instance health. That's our instance. It's IP colon 8080. Oh yeah, it's healthy. It looks good. So it's going to take some time to register in the load balancer. Once that is done, oh, it's in service. Good. Let's now access. Great. And we also have the database set up, so we can log in with admin_vp user. Right, that's our admin username. The password also same, and a complete connection. Logged in, connected to the database also. Okay, so that's a complete flow. Now you can add more things, right? You don't want to use local instance for the database. You want to use RDS. Well, you can set up RDS. Just go to the documentation, find out how you can set up RDS, and you can do that. So I will show you how to set up RDS also. Now, if things are clear, I'm going to run you through some scripts that I already have with me, and I'm going to explain you. Okay, not execute them. So let's go to script RDS. Security group. Okay, so here comes the notepad++. Okay, so this is a security group file, and you see I'm creating here two security group. One, this is for the instance, the other one is for the RDS. Okay, so similar things in RDS, except we are going to accept connection from port 3306 from the security group of the instance. So first this security group will get created, then in RDS security group we are allowing, so instead of CIDR blocks we can give security groups, and can give the ID of the security group. So any instance that belongs to this security group can access this security group on port 3306. Right, this is security group for RDS. Now let's check the RDS. So for RDS, you also need to create DB subnet group. By default, it gets created. We have not created. Subnet group for RDS is just collection of the subnets. So if you want to do that, you can do it. Create your own DB subnet group. Okay, like this. So this is the resource name, and you have to give the name, and you have to give the list of subnets. Now here, var.sub1. Now here it will be this variable you have to define. I have defined that variable. Let me show you into the variables file. Sub1. So that is subnet 1 ID. This is subnet 2 ID. Okay. So I'm using that variable and creating a subnet group. Once the subnet group is created, then I can refer that subnet group while I'm creating the RDS. And here I'm creating the RDS. AWS DB instance, name, allocated storage, storage type, engine. Be careful when you are launching RDS through Terraform, and make sure you give dbt2 micro. Otherwise, if you don't mention, it's going to create a larger instance. It will be multi-AZ and there will be charges. Okay, so make sure this one and multi-AZ false you give. Now in current version of Terraform, anyways, multi-AZ is false by default, but don't take any chance. I don't know what version you'll have in the Terraform. So give multi-AZ false and instance type dbt2 micro. So you'll be sure that, and also storage type GP2. So you'll be sure you'll get created in free tier. Okay. One more thing, skip final snapshot true. So when I'm going to destroy this, when I create RDS, when you create the RDS from this, and when you say Terraform destroy, then it will keep the final snapshot. Now snapshot is going to be of a 20 GB of volume, so it's not going to be free. So when you destroy and you have this setting, then it will make sure that it doesn't take a final snapshot. This is only for the learning and testing. In real time, you should take a snapshot before you delete the RDS. Okay. And where did I get it? Very simple. Terraform documentation. Okay. Let me show you RDS. RDS resources, AWS DB instance. See the example? You can just copy paste, and you can then change and use different values, right? Like deletion protection, you don't want it to get accidentally deleted. You can enable that. Instance class, IOPS if you want provisioned IOPS, right? Monitoring, if you want monitoring window different, monitoring interval different, right? When we create RDS, we give so much of information, port number, you want a different port number, public accessibility. So by most of the time, you should actually have it private. Some instance you want public accessibility, then you give it yes. Okay. Default is false. So by default, public accessibility will be denied. Okay. And security group names, skip final snapshot, so many settings, right? So you can really launch then the RDS. Right. What else? Okay, now when you're using RDS, then you don't need to set up database on the Tomcat instance. So in your script, don't have the MySQL setup, but have this thing. You need to restore the database. So we set up the Tomcat, you clone the source code, and it's not here. Hold on a second. Should have given it. So you have to give a MySQL command. Wait. Is this one? No. I think I have not included it. But you have to give a MySQL command which will now take your SQL file and deploy it into the RDS. Okay. Okay. All right. Now, one last thing over here. Now, when you're setting up RDS, now when you set up RDS, it will return the endpoint, and that endpoint should be there in our application.properties file. And our application.properties file is a static file. Okay. Now, if you remember the template in Ansible, I'm going to talk about same thing, but this is little more complex. So if you get this, fine. If you don't get this, do it later. Okay. It's the same concept like template. Template in Ansible is a file where you can put variables. Here also same concept, but here you have to do some more work. So first we'll create a template. Okay, so like I have this template. Okay, application.properties file as a template, and I've mentioned a variable here. Okay, RDS endpoint. Now this is my own custom variable. This doesn't come from anywhere. Okay, I have to assign some value to this, and that I can do it. And one more template, which is my script. That's my script, and here I'm running. I told you, right, when you set up, you clone the source code, you take your SQL file, and then you deploy it to RDS endpoint, right? RDS instance, right? But once the RDS instance get created, then only you're going to get the endpoint, and then later you have to put it into this file. So that will be two things, right? If you want to do it in a workflow, then you should get automatically the endpoint, feed it into your scripts and your configuration files. That can be done through templates. So RDS endpoint there in the script and also in application properties file. And that value, how I can generate, well, I'm going to write, hold on a second, where is that? Just a moment. Yeah, okay, fine. Here itself, I put it in here itself. I thought I put it in different file. So data template file, it's not a resource, it's like the data we are using. Okay, so template underscore file, give some name for your resource. Template is equal to your file. Now this is my application.properties file as a template, right? This one. And I'm saying that this is the template load, and in this there is a variable RDS endpoint. Its value should be this, which is the endpoint of the RDS instance, again from the data source. Webro RDS, right, that we created in the RDS file. So this is going to return the endpoint that will be assigned over here. Okay, that's fine, but and again we are doing the same for the script file also. In the script also we have RDS endpoint, so we are also mentioning that. But then you have to render this template, so you can do that through user data. Now this is a little advanced section in Terraform, user data, where you can upload template files also. So data.template underscore file ap-template.rendered. Okay, this one. Okay, then this next one is this one. Right, in Ansible it's simple, right? In the template file we mention the variable, we define its value, and then by using a template module we push it. Okay, here we push it through user data, but the template value should be replaced, and that we do it through data template file. Okay, go through this later, right? Just understand that as of now, understand that there is a way I can use templating kind of thing what I have used in Ansible. Okay, once you do this by yourself, you'll will be able to understand, but relate it with Ansible template, it's similar to that. Okay, but little more extra work you have to do. You have to give here the data template file. Okay, so that's about template, right? Nice. All right, so yeah, that was about the vProfile setup, right? So you can have template, you can have RDS, you can have load balancer, EC2 instance, you can have EBS. Just go through the documentation, find you can use S3 bucket, resources, water resource. Keep one thing in mind, people. Okay, whatever you're doing through automation, you should first know how to do it manually. If you don't know how to do it manually, then writing a script for that will be disaster. Okay, you will spend numerous hours, will waste a lot of time. So make sure whatever resource you get, first you know how to do this manually. Do it manually. If you going up with a new service in AWS, you don't know, I never used it, use it first manually. Okay, try it, right? Get the recommendation from architects and all, how do you want to use it, do it manually. And then same thing you have to write, and for same thing you have to write the script. Okay, so it's easy for me to write the RDS and things that I've already used, VPC and all. But if you ask me something like APN gateway or something else that I've never used, I won't be able to do it, right? Or I may try and fail and try and fail and try and fail, and I'll waste numerous hours. Okay, I may get it right sometimes, but again, if the problem comes, I have to troubleshoot, I won't be able to do. So you should first know how to do things manually. And you already know AWS and what are services we are used. I'm focusing only on that for in the Terraform, not anything else. RDS, S3, ELB, EC2, all this, right? EBS also try snapshot. Take that as an exercise. It's very easy. Taking snapshot through Terraform, and then you can use that script and put it in a cron job. So if you want like regular snapshot, some people say I want regular snapshot. So I told you, if you have an automation tool, you can automate that, right? So Terraform is the automation tool. So write a script where it takes the snapshot, simple thing, and then put it into a cron job. Okay, you sometimes have to integrate Terraform with Ansible. So there is no direct integration as of now. So you can use something like local exec, which I'll show you, and generate the inventory file. So workflow is like that. It set up the infrastructure, gives you the IP address, and that IP address you put it in the inventory file. Okay, but how about it automatically puts that information into the inventory file? So you can write a script, a bash script or a Python script, which first execute Terraform apply. Once that is done, then it will automatically execute your Ansible playbook. So that will be like a workflow created by you yourself. So there is no direct integration between Terraform and Ansible. Okay, so you have to combine it in a workflow. I'm sure they'll be coming up with the integration, but as of now, it's not there. So you can use local exec. Let's see if I have local exec for you. Remote exec will execute commands on the remote machine. Local exec is going to create it locally. Yeah, see local exec. So you can use local exec, and then you can echo the IP address to a file, which can be an inventory file, but you have to echo it properly, right? Like instance name, then the IP address like that, or you can put that information into the host file, right? Not in the inventory file, it is the host file, and inventory will pick up the name from there, right? So you have to come up with such kind of solutions, right? So for previous batches, not the latest batch, let me go and talk about VPC. Let me show you an example of VPC. How did I set up the VPC? Yeah, one last thing for today. Okay, VPC. Now you should know again how to do VPC manually. Okay, so for new batch you don't know. For the previous batches you know how to set up VPC, right? So this is through Terraform. Resource AWS underscore VPC. Name of the resource, then CIDR block, instance tenancy, DNS support true, DNS hostname true, the tag. This will create the VPC, and then the subnet inside the VPC. So AWS subnet. So then you have to again mention the VPC ID, in which subnet it should get created. Again, you see we are using the data source AWS underscore VPC, right? That one, vprofile, one dot ID. So when this gets created, its ID you can acquire by this data source, and then you can feed it over there. Then CIDR block, availability zone. So this is one zone, sorry, one subnet, then the another subnet, right? In another zone 2B. Again, you can put this into variable files also, zones. Okay, then one more subnet, 3 public subnet, 3 private subnet. You see, once you know how to do it, it's all about documentation, right? Internet gateway, of course you need internet gateway for public subnet, so launch an internet gateway, right? It's easy to set up, just mention the VPC ID, and that's all. Then the route table, of course, right, which will make sure it routes to the public subnet, routes to the internet gateway. So route table, the route table name, VPC ID, then routes. So 0.0.0.0/0, all the traffic goes to the internet gateway. See, So if you know how to do it manually, then reading the documentation becomes very easy. And then just have to put it in a file. Right? Then subnet association. You have created route table, you have internet gateway, you have subnet, you have VPC. Now it's time to connect them through route table. So associate route table to the subnet. So subnet ID and the route table ID. Again, I'm getting it from the data sources. Right? So I've not created here NAT gateway because I thought people may accidentally, without looking, set up the NAT gateway and then will say, oh, I'm getting huge bills. So as I've set up the internet gateway, similarly, there is another resource to set up the NAT gateway, and then you have to add it, create a new route table similar to this, and do a subnet association for the NAT gateway. Right? Now, if you know this VPC already, and if you know how to write Terraform, you see how easy it is. Like that, there are plenty of resources you can play with in Terraform. Right? And that would be the end of the session. Any questions? Hello?
So Imran, I think we need to practice now.
Yes, you need to practice, of course. So I'm going to send you all these scripts, okay? Start one by one. Don't use my scripts. My scripts will be only for reference. Write your own. You get into problem, very good. Read the error, solve the problem. Okay? Some errors may take even a week time for you to resolve. Okay? Don't get disheartened. All right? Keep trying. Okay? And this is one very popular tool now. It's going to pick up a lot. So make sure you practice this. Okay? Fine then, people. Thank you for joining. I hope you enjoyed the session.